molecules. He categorized the speeds as root mean square speed, average speed and most probable speed. So let's begin with the most probable speed. This is the speed possessed by maximum number of molecules. Suppose there are 100 molecules and out of which 60 molecules possess some speed. So the speed which is possessed by maximum number of molecules is the most probable speed. Maxwell through his experiments assigned the value root 2 RT by m to the most probable speed, which is also equal to root 2 b by rho, which is also equal to root 2 kt by m. Here R is gas constant, m is molar mass in gram, T is the temperature, P is the pressure, rho is the density, K is Boltzmann constant, and small m is the atomic mass in AMU. Now talking about the graphical analysis of the parameters, the first relation is Vmp is proportional to root T. So if I draw the graph between Vmp and T, it's a parabola. Secondly, if I draw graph between Vmp and m, it's a rectangular hyperbola. Secondly, we have for root mean square speed as root 3 RT by m, which is root 3 kt by m, which is root 3 p by rho. Similarly, the graph of Vrms versus T will be a parabola, while that of Vrms and m will be rectangular hyperbola. For average speed, we have V average is root 8 RT by pi m, root 8 kt by pi m, 8 p by pi rho. V average T graph is a parabola, V average m graph is a rectangular hyperbola. So this is the way how speed can be categorized. So you have seen that it's very easy to learn and retrieve information in your mind if you have stored that information in a systematic way. So work on the process that you use to learn information, to store information in your mind. Only then you will be able to retrieve it as and when needed, and you will be having a sharp problem solving skill. So work on quality of working. Thank you and have a nice day. Good morning everybody. Myself Vishvendra. I am the founder of Optimal Success Trajectory. Let's discuss the molar heat capacity of a gas in a process. So suppose we have an ideal gas and we supply an amount of heat delta Q to the gas. As an impact of that, it performs our delta W and its internal energy increases by delta U. So using first law of thermodynamics, we can say that delta Q is equal to delta U plus delta W. Now, we know that delta Q can be written as NC delta T. Delta U is NCV delta T plus delta W. Equation of the gas is P V raised to power n is equal to K, which is constant. So we can say that P is equal to K V raised to power minus n. Now, the work done is integration of PdV from V1 to V2. So if we substitute the value of P, so P is Kv raised to power minus n in dV. So if we integrate that, K is a common, so it will come out, and the integration of V raised to power minus n will be V raised to power minus n plus 1 or minus n plus 1 from the limit V1 to V2. So after we substitute the limits, we get K 1 by n minus 1, V2 raised to power 1 minus n minus V1 raised to power 1 minus n. Multiply this expression by K, we have worked done as K V2 raised to power 1 minus n minus K V1 raised to power 1 minus n divided by 1 minus n. Now K is equal to P2 V2 raised to power n is equal to P1 V1 raised to power n. So if we substitute the value of K, then we have delta W is equal to P2 V2 raised to power n V2 raised to power minus 1 and 1 minus n minus P1 V1 raised to power n multiplied by V1 raised to power 1 minus n divided by 1 minus n. So here we take the base common and these n will cancel out and we will have